morning, my dear students. Today in this video I'm going to discuss some of the important questions from exercise 12.3. We'll be starting with the first question. Find the area of the shaded region in this given figure where your PQ, the length of PQ is given to be 24 centimeter. Your PR is given to be 7 centimeter and O is the center of the circle. So using this information in the given figure, we are going to find out the area of this shaded region. Now, it is given that the side PQ is equal to 24 centimeter and PR is equal to 7 centimeter. Now we know that in a semicircle, you consider a semicircle. Here, suppose PQ, if this is a semicircle, then PQ is the diameter of the circle or of the semicircle. If this is a semicircle, then PQ is the diameter of this semicircle. Now, let me mark any point R on the semicircle. Let us form an angle at this point R. So what we need to do is, we need to draw a line joining Q and R. And we also need to draw a line joining P and R. So the point R has been joined to two ends of the diameter. Then the angle formed at this point R is 90 degree. That means the angle in a semicircle, is a right angle. And as such, angle PRQ, the angle formed here is PRQ, angle on the semicircle is your PRQ. So angle PRQ is equal to 90 degree. So this is an important theorem that we are going to use here, which we have already studied in class 9. The angle in a semicircle is always a right angle. So in the given figure, this is your semicircle, this is your semicircle, this particular region is your semicircle. This particular region is a semicircle, and then this is an angle. This is a semicircle. P is a point on the semicircle, so the angle on the semicircle is a right angle. This is a semicircle. P is a point on the semicircle, so the angle formed at this point will be 90 degree because the angle in a semicircle is a right angle. So the angle, this angle will be named as angle QPR. Angle QPR is 90 degree because the angle in a semicircle is a right angle. So angle QPR is equal to 90 degree because angle in a semicircle is a right angle. Now, since this angle is a right angle, in that case, your triangle PQR becomes a right triangle. And knowing two sides of a right triangle, we can find out the third side of the right triangle using Pythagoras theorem. Now, in this right triangle, PQ is given to be 24 centimeter. PR is given to be 7 centimeter. So we have to find out the length of QR, the length of the side QR. Now this side QR, okay, is opposite to your right angle. So QR is always the longest side, known as the hypotenuse. So in right triangle PQR, by applying Pythagoras theorem, Pythagoras theorem states that in a right triangle, the square on the hypotenuse is always equal to the sum of squares on the other two sides. In this right triangle, QR is the hypotenuse. Okay, so QR is the longest side because hypotenuse is always opposite to your right angle. Okay, so the square on the hypotenuse, so QR square will be equal to the sum of squares on the other two sides. The other two sides are PQ and PR. So PQ square plus PR square. Now QR, we are going to find out this. So QR square equal to PQ. Your PQ is 24 centimeter and we have square. Your PR is 7 centimeter and we have square. So this implies QR square is equal to 24 square gives you 576 centimeters square as well. 7 square is 49 and then we have centimeters square. So your QR square would be equal to 576 plus 49 gives you 625 centimeters square. So QR will be equal to square, you transpose it, then it becomes square root. And square root of 625 is 25. Square root of 625 is 25. Square root of centimeters square is centimeter. So the hypotenuse has been obtained. Now, since we have obtained QR, for this circle, QR is the diameter. QR is the diameter of the circle. So since we have obtained the diameter of the circle, so we can obtain its radius. So diameter of the circle is 25 centimeter. Okay. This hypotenuse of this right triangle is the diameter of your circle. Okay. So the diameter of the circle is 25 centimeter. So therefore the radius will be 25 upon 2 centimeter. Radius means half of the diameter. If QR is the diameter, then OQ and OR are the radius. Okay? So diameter has been formed by 2 radius. So the radius will be half of the diameter. Now we are asked to find out the area of this shaded region. So area of this shaded region can be found out by, okay, from this particular region. This particular region is your semicircle, right? This particular region, OQPR. This OQPR is your semicircle. From this semicircle, if we subtract this triangle, okay, from the area of semicircle, if we subtract the area of the triangle, then we get the area of shaded region. Therefore, your area of shaded region will be from the area of semicircle. This OQPR is your semicircle. So from this semicircle, if we subtract the area of this triangle, then we get the area of the shaded region. So area of shaded region means area of semicircle minus area of triangle PQR. Now area of semicircle. Semicircle means half of this circle. So area of semicircle will be half times the area of circle, pi r square. Minus area of triangle, half base into height. For this triangle, the perpendicular sides will be the base and the height. So half into base PR into height PQ. In the right triangle, the perpendicular sides are the base and the height. So half into pi means 22 upon 7 r square. The radius is 25 upon 2 centimeter. R square means r times r. So I'm going to write 25 by 2 centimeter times 25 by 2 centimeter minus area of the triangle, half into PR into PQ. Your PR is 7 centimeter and your PQ is 24 centimeter. We can cut out some terms here. 2 11 times is 22, okay, and here 2 12 times is 24. Now we're going to multiply. 25 times is 625. 625 times 11. 625 times 11 will be 1 5 times is 5, 1 2 times is 2, 1 6 times is 6. 5 2 6, so we have 5 7 8 6. So 6 8 7 5. 6 8 7 5 upon 2 times is 4, 4 7 times is 28 centimeter into centimeter square minus 12 7 times is 84 centimeter into centimeter square. Okay, so we can evaluate this by taking LCM. Alright, so if this part is done, I'm just going to wrap it out, okay, so that I have enough space for the remaining calculation. So your area of shaded region will be 6,875 upon 28 centimeters square minus 84 centimeters square. What we can simply do is, instead of taking LCM, we can simply divide these two terms and subtract it with 84. So let us see the division. 6875 upon 28. 28 2 times, 2 8 times is 16, 1 carry, 2 times is 4 plus 1 5. 8 minus 6 2, 6 minus 5 1, we have 7. 28, let's go for 5 times, say 5 8 times is 40, 4 carry, 5 2 times is 10, 14, that is too large. So let's go for 4 times. 4 8 times is 32, 3 carry. 4 2 times is 8 plus 3 11. So 4 times is 112. 7 minus 2 5, 2 minus 1 1. We have 5 coming down. Okay. 28 5 times is 140. So we have 5 here, we have 1 here. Okay, so we put the decimal and bring down 0. We have again 5 times as 140, so we have 0 here, we have 1 here, we have decimal, so we can bring down another 0. Let me go for 3 times. 3 8 times is 24, 2 carry, 3 2 times is 6, plus 2 8, 10 minus 4 6, 9 minus 8 1, we have decimal, so 0, 5 times is 140. I think that should be enough. After decimal we have taken up to 3 digits, so that should be enough. So this division gives you 245.535 centimeters square minus 84 centimeters square. Okay, 84 square centimeters. So let us subtract them. 245.535 minus 84.000. When you're subtracting, okay, any two terms containing decimal, then their decimal should coincide. 84 does not have any decimal place, so we write 84.000 and we subtract them. 5, 3, 5, 5 minus 4, 1. We cannot subtract 4 and 8, so we'll go for 14. 14 minus 8, 6, and then we have 1 over here. So the area of the shaded region is 161.535 square centimeter. So this is your required area. Yes. So if this is done, we can go for the next question. Now we have question number 2. Find the area of the shaded region. So your shaded region, this particular region is your shaded region. Okay. This particular region, this ACDB, this particular region ACDB is your shaded region. So we want to find out the area of this shaded region. In this figure, if the radii of two concentric circles with center O are 7 cm and 14 cm respectively, and the angle here at the center, angle AOC, angle at the center is given to be 40 degrees. Now we have two given circles. Both of these circles has the same center O, so concentric circles. Alright? So concentric circles means circles having the same center are known as concentric circles. So we have two circles, both the circles have the same center O, so concentric circles. The radius of the two circles are given to be 7 cm and 14 cm respectively. That means the radius of the inner circle is 7 cm and the radius of the outer circle is 14 cm. So I'm going to write what is given. So it is given that the radius of inner circle, so the radius of inner circle R is given to be 7 cm, and for the outer circle the radius is 14 cm. So radius of outer circle, capital R, is given to be 14 cm. Also it is given that angle AOC is equal to 40 degrees. Also angle AOC is equal to 40 degrees. Now if we look at the figure very carefully, we see that this shaded region is enclosed between two sectors. Here AOC is your bigger sector. Here this AOC is your bigger sector and BOD is your smaller sector. Okay, we already understood what is a sector in the introduction of this chapter. So let me not repeat anything about the sector, but from the figure we clearly see that this shaded region is enclosed in between two sectors. One is the bigger sector AOC and one is the smaller sector BOD. So from the bigger sector, if we subtract the smaller sector, okay, from the bigger sector AOC, if we subtract the smaller sector BOD, then we get the shaded region. Both the sectors subtends the same angle at the center. Okay, so the angle of the sector for both the smaller sector and the bigger sector will be 40 degrees. So the area of shaded region will be given by area of bigger sector. Area of bigger sector minus area of smaller sector. Area of smaller sector. Now, the bigger sector, okay, has radius 14 centimeter and the angle of the sector is 40 degrees. For the smaller sector, the radius is 7 centimeter and the angle of the sector is 40 degrees. Both of the sectors, the bigger sector and the smaller sector, they subtend the same angle at the center. See this, just look at this sectors, this smaller sector, it subtends 40 degrees at the center. The larger sector also subtends this 40 degrees at the center, alright? And we know that the area of sector is given by the formula pi r square theta upon 360 degrees. Pi r square. For the bigger sector, radius is capital R. So pi capital R square theta upon 360 degrees minus area of smaller sector pi small r square theta upon 360 degrees. We can take out some terms common here. Pi is common, theta is common, upon 360 is common. So we can take pi theta upon 360 common. Then from this term we will have capital R square minus from this term we will have small r square. We can use pi as 22 upon 7 because nothing is specified over there. So pi means 22 upon 7. Theta is 40 degree divided by 360 degree. Capital R square. Capital R square means capital R times capital R. So 14 centimeter into 14 centimeter. Minus small r square means small r times small r. Small r is 7 centimeter. So 7 centimeter times 7 centimeter. Now this is equal to, okay, we can cancel here 40 degree, 9 times is 360 degree. Alright, so what we have here, so this is equal to 22 upon 7 times 9 is 63. And then we have 14 centimeter into 14 centimeter is 196 centimeters square. 7 centimeter into 7 centimeter, 49 centimeters square. So what we have is 22 upon 63 times 196 minus 49. 196 minus 49. 16 minus 9. 7. We have 8 over here. 8 minus 4. 4 and then we have 1. So times 147 centimeters square. So 9 times is 63, alright. 2 times is 14, 1 times is 7. 3 times is 9, 7 times is 21. So 22 times 7, 7 2 times is 14, 7 2 times is 14 plus 1, 15 upon 3 centimeters square. If you divide it, then 3 5 times is 15, 3 1 times is 3, 3 3 times is 9, 3 3 times is 9 centimeters square. So your required shaded region is 51.33 square centimeter. That's the answer for the shaded region. Now we have question number 3. Find the area of shaded region in figure if ABCD is a square of side 14 centimeter and this APD and BPC are semicircles, two equal semicircles. So given to you is a square, okay, and we want to find out the area of this shaded region. It's very clear from the figure that from this square ABCD, if you subtract these two equal semicircles, that is APD and BPC, then we get the area of shaded region. Now the side of the square, okay, AB or BC, CD and AD represents the side of the square, and it is given to be 14 centimeter. So it's given side of square. Let me denote it by A. The side of the square is 14 centimeter. Now, this side of the square gives the diameter of each of this semicircle. For this semicircle, the side of the square is your diameter, and for this semicircle also, the side of the square is your diameter. Now, how do we know that these two semicircles are equal? Because both of these semicircles have the same diameter, right? Okay, because they have the side of the square as their diameters, and the side of the square is 14 centimeter. So the diameters of the semicircles are equal. Okay, so in that case, the two semicircles are equal. So the diameter of semicircle will be the side of the square, that is 14 centimeter, and therefore the radius of the semicircle will be half of the diameter, that is 7 centimeter. That is 7 centimeter. So in order to find out the shaded region, what we have to do is, from the area of square, we subtract the two semicircles, that is APD and BPC. So area of shaded region will be given by, from the area of square ABCD minus area of two semicircles. Now, area of two semicircles gives you area of circle. So I'm going to write area of circle. Area of circle, okay, because area of two semicircles gives you the area of circle. So area of square is given by side square, and area of circle is given by pi r square. Side is 14 centimeters, so 14 centimeter holding square. Pi is 22 upon 7 into r square, means radius into radius, r times r. So that is 7 centimeter times 7 centimeter. For this a square means a times a. So that is 14 centimeter times 14 centimeter. That's how we can write. Now 14 times is 196 centimeters square. Here we can cancel 7 2 times is 14, centimeters square. So if we subtract them, 6 minus 4 is 2, 9 minus 5 is 4 square centimeter. So the area of the shaded region has been obtained to be 42 centimeters square, which gives the complete solution for this question number 3. Now what we have is, we have question number 5. Okay. From each corner of a square of side 14 from each corner of a square of side 4 centimeter. So we have a square of side 4 centimeter. A quadrant of a circle of radius 1 centimeter is cut. So from each corner of this square, a quadrant of a circle has been cut with radius 1 centimeter. That means the radius of each of this quadrant. This is a quadrant of a circle, the radius is 1 centimeter. This is also a quadrant of a circle, radius is 1 centimeter. Okay, 1 centimeter. And then this is also a quadrant of a circle, radius is 1 centimeter. This is also a quadrant of a circle, radius is 1 centimeter. So from each corner of this square, a quadrant of a circle has been cut off with radius 1 centimeter. And also a circle of diameter 2 centimeter is cut off. From the center of the square again, another circle has been cut off, but the diameter of this circle is 2 centimeter. Diameter is 2 centimeters. Okay. Find the area of the remaining portion of the square. Now from this square ABCD, if you cut 4 quadrants of a circle from each corners with radius 1 centimeter, and another circle at the center of the square with radius or with diameter 2 centimeter, then the remaining portion will be given by the shaded region. Okay, as indicated in the figure. The remaining portion will be given by the shaded region as indicated in the figure. So the radius of each quadrant of the circle, R is given to be 1 centimeter. Okay, so 4 quadrants of circle has been cut off as shown in the figure. The radius of each of this quadrant is 1 centimeter. And then another circle with diameter 2 centimeter is cut off. So the radius of this circle, radius of the circle at the center of the square is given, the diameter is given. The diameter of the circle at the center of the square is given to be 2 centimeter. So the radius will be only 1 centimeter. Half of the diameter is your radius. Okay, that means the quadrants and the circle, they all have the same radius. So I've denoted by small r only. So we want to find out the remaining portion of the square. And your square, it has a side 4 centimeter. So side of this square, A, let me denote by A, 4 centimeter. So area of remaining portion. So area of remaining portion. Area of remaining portion will be given by the area of the square, minus, okay, from the area of square we'll subtract 4 quadrants of the circle. So 4 times area of quadrant, area of each quadrant, alright, of circle, minus the area of the circle at the center of the square, minus area of circle at the center of the square. Now, area of square is given by side square, 4 times area of quadrant. Area of quadrant of the circle is 1/4 of the area of circle, minus area of circle is again pi r square. So here 4 can be cancelled out. So what we have is a square minus, we have pi r square minus pi r square. Pi r square minus pi r square gives you minus of 2 pi r square. So now the side of the square is 4 centimeter. A square means 4 centimeter into 4 centimeter. 2 pi r square. 2 into pi is 22/7. The radius, okay, is given to be 1 centimeter. So radius square means 1 centimeter into 1 centimeter. 4 times is 16 centimeters square minus 44/7 centimeters square. So 16 centimeters square minus 44 divided by 7. Or what we can do is we can take LCM. LCM of 1 and 7 is 7. Okay. 7 will be divided by the denominator 1. Then 7 times 6, 16. 7 6 times is 42. 4 in hand. 7 1 times is 7 plus 4, 11. Minus 7 divided by 7 is 1. So 1 times 44 is 44 centimeters square. If we subtract them, 112 minus 44. 12 minus 4, 8. We have 0 over here, so we can take 10. 10 minus 4, 6. So 68/7 square centimeter. If you divide it, then 68 divided by 7. 7 8 times 7, 9 times is 63. We have 5 in hand, 5 carry. We put point and bring 0 down here. 7 7 times is 49. We have 1 over here, point, so 0. 7 1 times is 7. So that's enough. So your answer, the area of the remaining portion, is 9.71 square centimeter, which is the required solution. Alright, so we go for the next one.